We know that everything in this universe is made up of matter, and atoms and molecules are the building blocks of matter. After the subsequent discoveries of atomic model by J.J. Thomson, Rutherford, and Niels Bohr, and the discovery of neutron by Chadwick, now we know that the atom are made of negatively charged electrons and positively charged protons, and neutrally charged neutrons. There is a very positive region at the center of the atom. This is called the nucleus, where all the protons and neutrons stay together. As discovered by Chadwick, mass of neutron is almost the same as the mass of proton. The electrons are very much lighter than proton or neutrons, and they revolve around the nucleus in orbits. So, almost all the masses of the atom are concentrated in the nucleus, which makes the nucleus a very small and heavy region inside the atom. Now, how many protons are present in the nucleus of an atom determines its atomic number and is represented by Z. This number decides the type of the element as well. For hydrogen, Z is equal to 1, that is, 1 proton present in the nucleus of hydrogen atom. For carbon, Z is equal to 6. Therefore, 6 proton is present in the nucleus of the carbon atom. Now, how is the mass of an atom determined? Therefore, the nucleus of an atom consists of protons and neutrons. So, the mass is determined by adding the number of protons and neutrons. Protons and neutrons, that is, the mass number, are also called nucleons. Can you see what is the mass of a carbon atom? It has 6 protons and 6 neutrons, so its mass is 12. Is there any notation for an atom? Well, it is written as for example, nitrogen is written as. Now, what about hydrogen atom? Its atomic number is 1 and mass number is 1. Then one type of hydrogen atom can be written as. Did I say one type of hydrogen atom? Yes, because hydrogen atom has 3 atomic species: protium, deuterium, and tritium. We see that the atomic number of each is 1, but the mass number is different. That is 1, 2, and 3. Let us take another example, say carbon atom. Here, the atomic number is 6, and mass number in both the types are different, that is 12 and 14. Similarly, for chlorine, we have So, on the basis of this example, we can say that there are 3 isotopes of hydrogen, 2 isotopes of carbon, and 2 for chlorine. That is, isotopes are defined as atoms of the same element having the same atomic number but different mass number. The chemical properties of isotopes are similar, but the physical properties are different. Now, the question is, what should we take as the mass number. If the atom of the same element has different mass number, the answer is that we have to know the percentage of each isotopic form, and the average mass is calculated. Example, in the case of chlorine atom, there are two isotopic forms with masses 35 and 37 in the ratio of 3:1. So, the average atomic mass of chlorine atom is This does not mean that any one atom of chlorine has a fractional mass of 35.5. It means if we take a certain amount of chlorine, it will contain both isotopes of chlorine and the average mass is 35.5. Now, let us discuss about isobars. Let us see a calcium atom and an argon atom. Here, the mass number, that is the total number of nucleons, is the same in both calcium and argon, but they have different atomic number. So we can say that atoms of different elements with different atomic number and same mass number are known as isobars.